And number 9, find the y-coordinate for the point. So again, this is a question that's getting at what is this connection between points on the graph and the function. So remember, the y-coordinate is the output, which is f of the input, and the input is given to us as -6. So in this case, what's really happening here is I have to know that a point on the graph is an input-output pair, and they're telling me the input, -6, and they're asking for the output. And so that's really the question. Given the input -6, what's the output? Well, that's not actually a hard question because we have an algebra formula for the function. So again, I've got negative numbers, so I'm going to put that negative number in parentheses everywhere it appears. -6 quantity squared, that's -6 times -6 is positive 36. Positive 2 times -6 is -12, minus 3. So 36 minus 15 is 21. Number 10 says find the location of the point where the lines intersect. And so this is the idea that intersecting means that they have a common y-coordinate for the same x-coordinate. And so what that means is we can set these two equations equal to each other. Minus 3x plus 5 is a formula for the y-coordinates of the first line, and minus 2x minus 6 is a formula for the y-coordinates of the second line. And so for me to say I want the two y-coordinates to be the same means I'm setting these two things equal to each other. And so I'll figure out what x is required to make the two y-coordinates the same. Let me add 3x to both sides, that'll give me an x over here, and let me add 6 to both sides, it'll give me an 11 over here. So the solution of this is that x is equal to 11. Now it asks for the point, not just the value of x, but the point. So this is the x-coordinate, and in theory it means that the y-coordinate on both lines should be the same at that point. So it's a good opportunity to check. So the first line, the y-coordinate would be -3 times 11 plus 5 equals -28. So that would be the y-coordinate on this line. On the second line, I would have y equals -2 times 11 minus 6, which if I check is also -28. So that's the y-coordinate on that line. So sure enough, if I look at the x-coordinate of 11, then the y-coordinate on both lines are the same. That's exactly what we mean by the point of intersection. So the answer here is the point 11, -28. That's the both x and y coordinates of the point of intersection. The next problem, find the slope of the line. Well, the easiest way to find the slope of the line, well, there's two ways, I guess. One is we could try to identify 2 points on the line. That would be okay. But that might take a little bit of trial and error. The other thing is just to rewrite this in in slope-intercept form, and if it's written that way, we know that the number in front of the x is the slope of the line. And so that's a little bit more automatic. We don't have to do trial and error for that. So let me do it that way. So what I'll do is I'll first add 8x to both sides. Looks like that. And then I'll, 13. And then I'll divide both sides by -13. So y equals -8/13 x plus 4/13. So that looks pretty horrible, but remember, it's only asking for the slope. The slope is the number that appears right there. So that's all I have to do. I don't really need to worry about the other numbers or doing anything else with it. I just need the slope of the line. Number 12 is a straight-up problem using point-slope form. We use the same thing on the previous page. Y minus a y-coordinate that I know is the slope times x minus an x-coordinate that I know. In this problem, I don't have a choice. I'm being told that the y-coordinate I know is -6, and the x-coordinate I know is -10. We want to write this in slope-intercept form, so I want to work my algebra magic to rewrite this so that it looks like y equals. So the first thing I would do is resolve these minus negatives. That's just hard to look at. So this is just a rewrite, so I don't have quite so much to look at. So this is the same thing. Subtracting a negative is the same as adding. Now I would distribute the multiplication on the right, so that 7 times gets distributed that way, and then I can subtract 6 from both sides, and I'll have y equals 7x plus 64. So that'll be my answer for number 12. In problem 13, we're looking for the x and y intercepts. Again, this is the same idea that we had before, but now we're looking at this in terms of a linear equation rather than a linear function. And so it doesn't really mean anything differently. It just is written differently. So remember that x-intercept means where the y-coordinate equals 0. And the y-intercept is where the x-coordinate equals 0. And so, so actually in the language of equations, this is particularly easy to work with. We don't have to have an f of x that we have to think about. So if I tell you the y-coordinate is 0, that means that the equation is 2x minus 5 times 0 equals negative 40. And from that, it's easy to find the x-coordinate. You'll see you'll get 2x equals negative 40, which means that x equals negative 20. So in this equation, when the y-coordinate is 0, the x-coordinate is negative 20. And so that's my x-intercept, negative 20 x-coordinate, 0 y-coordinate. So similarly, when I want the y-intercept, that's where the x-coordinate is 0. And so I can just, in my equation, make the x-coordinate 0, and then solve for the y-coordinate. So in this case, the y-coordinate will be 8. I'll have the equation negative 5y equals negative 40, divide both sides by negative 5, and I get y equals positive 8. And so again, just doing what I said, x-coordinate is 0, y-coordinate is 8. So again, those are nice whole numbers. These are nice whole numbers. It's very easy to go back and just try that, put those back into the equation. Make sure you have the pairing right, the x-intercept and the y-intercept. Don't just write them randomly. The x-intercept should be a point on the x-axis. The y-intercept should be a point on the y-axis. The x-axis and 0, 8 would be on the y-axis. So as long as you're visualizing where these points would actually be plotted, you won't get them mixed up. All right, number 14 asks us to graph a function, and I think I mentioned in class that my recommendation here is to plot points. So there's the point 0, negative 7. So plotting the point when x is 0 is always super easy because you're just putting 0 in for x. Remember this equation here. So if you put 0 in for x, you get negative 7 for y. So just put another number that's easy in for x. There's no fractions in here, so just putting like x equals 1. If you put x equals 1, y will be negative 11, which is running off the graph, so that's a little hard to see. So maybe 1's not the best choice. So in that case, let's try negative 1. If you put x equals negative 1, then y is going to be negative 3. So negative 1, negative 3 is there. When x is negative 2, y is 1. And so you can see that we can find some points to plot that are have nice whole number values. And as soon as you plot, I recommend plotting 3, just because if those 3 don't lie on a straight line, then you know that you've messed something up. Did I mess something up? Negative 1. No, that's right. Oh, negative 7's down here. That's why it looks funny. Yep, see, I caught my mistake. Just get rid of that. So right off the bat, my 0, negative 7 was drawn incorrectly. But because I plotted 3 points, I was able to see that. So 0, negative 7 would be there. So I have, it's pretty hopeless to draw with this stupid pad anyway, but 0, negative 7, negative 1, negative 3, negative 2, 1. So those points do look like they fall in a line. So it's about as good as I can do. But anyway, on a test or something, make sure you draw the points that you're trying to say you're hitting so that you don't have me having to make a judgment call as to whether you were drawing the right thing or not. And of course, you'll have other paper, so slap a straight edge down and draw it as best you can. But show the points you're trying to hit, and that will always get you full credit. And then finally, 15 is just solving on your equation. We made sure it was one with fractions. You're welcome. But the idea here, remember, there's several different strategies, but one that I was advocating is If you don't like fractions, get rid of them. So if I multiply both sides of this equation by 3, then I should be able to get rid of the fractions, because when I do 3 times 5x over 3, those 3's are going to cancel. And so I'll just have 5x there. 3 times minus 6x is negative 18x. And 3 times negative 52 is negative 100 and whatever it is, negative 156. So after multiplying both sides by 3, I always do that. Times symbol should not be that. After I multiply both sides by 3, the fractions in the problem are gone, as long as I am careful about it and make sure that I really distribute multiplication through all the terms. And now I just have a normal linear equation, so I have negative 13x equals negative 156. And so, what is that? X is 12, I guess. Anyway, so as the last problem, you get to use some of your linear equation strategies. Okay, that's it.